Welcome to the class, student. Today we'll discuss parabola, conic section. We'll start with conic section. Here you see the student. Let us say that this is the line segment, marker. I'm taking here marker. I would like to say that what line segment, right? If you are going to rotate here with the help of this, there is a one diagram is formed. See this? The diagram is formed here. This diagram you can call it as what? Conic, right? So cone. So with the help of this cone, see here, suppose this is the cone here. Okay, you see here, this is generator. Generator you can call it as, and this one is axis. You are going to call this one as what? Axis, right? What is going to happen here? You see here, now this is a cone. Rough diagram I'm going to draw. You take a plane and it will be the perpendicular to axis. If you cut the cone perpendicular to axis, okay, plane is perpendicular to axis, then it become what? Circle. The shape whatever we'll get here is a circle. Now I would like to take one more cone like this, and at this time I want to cut the plane parallel to generator. Plane is parallel to generator. Parallel to generator, then the shape whatever you will get over here is parabola. See this? This is what? Parabola. Right? We got it here, parabola. Now I would like to take one more diagram. This time the plane is making some angle with the axis. Surely we may get a diagram in this form. Okay, it looks like almost right. Here it makes some angle with the x-axis. This is what? Ellipse. Okay, this is ellipse you are getting. The diagram, the shape whatever we are going to get over here looks what? Ellipse. Now the next one. You see here, I want to take like dumbbell, right? Like dumbbell shape I'll take. Okay, you say like, you take like this, and if you are going to cut, okay, if you are going to cut along with the parallel to axis, exactly parallel to axis with the plane, so now it will be like this, somewhere here, and it will go like this. The shape we are getting here is in this way, right? We are getting the shape in this way. You can call it as hyperbola. You can call it as hyperbola, right? Now another one. When you are going to draw the plane along the vertex, if you cut it off, you will get here like this pair of line, pair of straight lines. You will get what? Pair of straight lines. Okay, like this. Okay, now you see here definition of conic. The locus of a point which moves in a plane such that the ratio of its distance from a fixed point to its perpendicular distance, okay, from the fixed line is always constant is called a conic. Leave it. That means here in a plane, this is a fixed line, say L equal to 0, and there is a fixed point, say S is equal to 0. You take one point in a plane, in this plane, you take down in the plane. If you draw a perpendicular here, this is the perpendicular, and he said like this, okay, he said in this way. What is that? SP by PM is constant. Constant. This constant we are denoting with what? E. You can say that eccentricity. Okay, you can call it as eccentricity. E is called what? Eccentricity. SP by PM, he said. In other words, we can define like this. What is that? You see here, locus of a point P, the locus of a point, the locus of a point P such that, okay, such that SP by PM is equal to E. You can say that constant. Okay, constant, I said it to you, that eccentricity. The locus of the point P such that SP by PM is equal to what? E is where, you see here, where S, the fixed point, where S is a fixed point, where X is the fixed point called, right, called focus, and PM is the perpendicular distance. PM is a perpendicular distance from P to fixed line. Fixed line L equal to 0. Called, this fixed line is called directrix. Okay, the locus of the point P says that SP by PM is equal to E is called conic. You can say like this also. Right, one more point here. You see this is a fixed point. If you say that this fixed point is what, something alpha comma beta, and the fixed line, if you take here, this as what, ax plus by plus c equal to 0. Let us take down like this, and this is what you know very well, perpendicular we have drawn from point P. You take down x1 y1, right? And one more point I want to tell you, the line which is perpendicular to the fixed line passing to the focus is called what? Axis. Okay, you can say that axis of the conic. Now, according to the definition, according to this definition, what is said here? SP by PM is equal to E, or SP is equal to E into PM. Now SP, what is SP? You see that x1 minus alpha whole square, y1 minus beta whole square. You can say that like this also, sir. SP is equal to PM, right, is equal to E square into ax1 plus by1 plus c divided by here root over a square plus b square whole square. We got it like this, right? We got it in this way. So here what is going to happen here? You see this one, you can write like this also, a square plus b square into x1 minus locus of p, you can say na, locus of p, x minus alpha whole square plus y minus beta whole square is equal to e square into ax plus by plus c whole square. With this, it is very clear that second degree equation we are getting, and that towards second degree equation in terms of xy we are getting here. We got it 2 points from the previous definition. One is what? While writing SP by PM is equal to E. The question is here, E, what is that? The question is here, we can talk what type of conic we are going to get means here, if E is equal to 0, there are possibilities are there. If E is equal to 1, next one is if E lies between 0 and 1, and third is this, and the fourth one is if E is if E is greater than 1, and fifth one is if E is root 2 also you can say that, and sixth one is if E tending to what? Infinity also you can say. So if E is equal to 0, then you can say that then the conic is called circle. Simply you can say that conic is called what? Circle. Next, the conic is called parabola. When E is equal to 1. See this E, don't get confusion. E means don't take that logarithm base E is the natural logarithm, E value is 2.732. No sir. Here we are indicating, we are saying that what E means eccentricity. That E is different and this is different. You see E is equal to 0, we are saying E is 1 equal to saying, that is not possible there. That E is what? 2.732. This is different. So now please remember, here if it lies like this, then the conic is called ellipse. Right? And the conic is here, you can call it as what? Hyperbola. Now this is what? Rectangular hyperbola. Rectangular hyperbola. You can say that. And last one is pair of straight line. Okay, pair of straight lines we are going to get. Now as I said it to you that just now we got it into this form. A square plus x square x minus alpha whole square plus y minus beta whole square. Okay, like this E square into ax plus by plus c whole square, we got it. This is also a second degree equation we are getting. Now the second degree equation, it represents what? What type of second degree equation? All second degree equation, can we say that conic? No. So here after this one, you see here one more point you have to know, that is related to second degree equation. What is the second degree equation here? See this. Suppose the equation is like this: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. And you know very well that you have learned this one in the case of pair of straight lines, right? In the topic pair of straight line, as well as in the case of what? Circle, etc. All those things. Now you see what happened here means delta. First of all, delta means ABC plus 2fgh minus af square minus bg square minus ch square it is. Or else people want to write like this also. Yeah, you can write like this also. Right, either this or this one you can say. Right, delta is this one. Now related to delta, we are getting what? Two things. One is if delta is equal to 0, the other one is delta is not equal to 0. If delta is equal to 0, and few cases, h square is equal to ab, right? And the next one is h square is greater than ab, and the next third one is h square is less than ab. We are getting, if h square is equal to ab, what is that? Pair of parallel line. Pair of parallel lines. You can say like this. This is also what? Pair of lines. Pair of intersecting line. Pair of intersecting line. You can say the intersecting line. This is what? Imaginary lines with, see here, imaginary lines with real point of contact, point of intersection. A real point of intersection, you can say like this. This is what? H square, remember, like this. Now another case, what is the? Delta not equal to 0, but here h square is equal to ab is 0. For example, you got it 0, right? H square is equal to, okay, take 1. What is that? H square is equal to 1. H square is equal to ab is equal to 1, you can say. Another one is h square is less than ab, you can say. Not 1, it is 0, sorry. And the next one is h square is greater than ab also, you can say, right? And next one is or you can say this one is h square is equal to ab. This is what? Parabola. This is ellipse. This is hyperbola, right? This is hyperbola. And h is equal to 0, a is equal to b, you can say that fourth one, right? Circle. delta not equal to 0 under this all cases. Okay, like this you can say here a plus b. Another case is also there. Please remember, fifth one, you can, people are going to say like this also, h square greater than 0, a plus b is equal to 0. They'll say that rectangular hyperbola. Rectangular hyperbola. Rectangular hyperbola, you can see. I'll write here clearly. Hyperbola, rectangular hyperbola, they can say. These are the cases you see here. If this type of equation given, one is what, related to delta equal to 0, the other one is not equal to 0. In not equal to 0 also, please remember parabola, ellipse, hyperbola, circle, right? And also what, rectangular hyperbola we have. Now see here how to find the, for example, second degree equation is given, ax square plus 2hxy by square 2gx 2fy plus c equal to 0. Second degree equation is given and it represents some conic. Is a conic. Is a conic means you know very well that delta not equal to 0 compulsory. Now how to find the center of the conic means, right, center of the conics. You see here, center of the conic is, you can write like this, hf minus bg by ab minus h square, next gh minus af by ab minus h square. This is the center of the conic. Now the question is, suppose you forgot this equation, I mean this, okay, we may have a doubt about this, whether it is gh minus af or ga minus af. If you have a doubt, don't worry, you treat this as what, s. What I am saying here, dou s by dou x. You differentiate this equation with respect to s and equate it to 0. What happened here? You see this 2ax partially, sir. This is the meaning of this one, is differentiate partially with respect to x. That means y is constant. So now 2hy we are getting and 2g we are getting like this. Now dou s by dou y, you do it. You are getting here 2hx plus 2by plus 2f you are going to get. After avoiding this 2, see this, after avoiding this 2 in both the equation, okay, the point of intersection of this, point of intersection, if you say that these are two lines, the point of intersection is the same thing you will get here, hf minus bg by ab minus h square, gh minus af by ab minus h square. You will get like this. Now we'll do one problem on it. You see here I have taken one example. What is that? 13x square minus 18xy, 37y square, 2x, 14y minus 2 represent what he said. So at that time what I did here, I compared a, b, c and gf values. I got it and I started substituting these values in the formula, that is what, delta. I am trying to find whether delta is equal to 0 or not. So I substituted here, you see here, I substituted a is 13, b is 37, c is equal to minus 2 and g is what, 1 and h is equal to minus 9. Yeah, I substituted like this, h is equal to minus 9 and f is what, 7. I substituted in this one. I got it here 1600. Delta is not equal to 0. Confirm that it is conic. Now what is the next one? H square is, you see here, h square. What is h square here? You see this one, h is minus 9. Minus 9 whole square is nothing but 81, we got it. What about AB? A is what, where is 13 and B is 37. So this is nothing but what, 481 we are getting. So h square minus AB means 81 minus 481, that is what, minus 400 we are getting. H square minus AB, that is h square is less than AB, less than 0. So h square is less than AB, so that we got this condition, delta not equal to 0 and also h square is less than AB. So the given one, given is ellipse. Given equation or given one, whatever you want, you can say that one. Given one is represent what? Ellipse. Like this we are going to find. Whatever it may be the equation is given, we are going to find like this. And if you want to find the center, I said it to you that just to differentiate. What I said it to you that You see here, dou s by, very simple, dou s by dou x. You see this 13x, 26x, sorry, 26x you are getting. Here minus 18y you are getting, and plus 2 is equal to 0. You can say another one is dou s by dou y. Dou y means the first one is gone, minus. Here it is minus 18x you are getting, and here 74y you are getting, right? 74y you are getting, and next one is what? 14 equal to 0. Solve this one, you will get the center of that ellipse. You are going to get like this. Once in the examination, he has given like this, the conic represented by the equation. See here, it is not a, though it may not be a equation of second degree xy equation, but he has given like this, means you can, okay, after squaring on both sides, there is a chance to get second degree equation only. Need not worry. So 2 root of ax root by is equal to 1, we got it. Or you can write ax plus by minus 1 minus 2 root of ax minus root by. Again you go for squaring. You will get here a square x square plus b square y square plus 1 plus 2abxy, right? 2abxy minus 2by minus 2ax is equal to 4abxy. You are getting like this. After simplifying, a square x square minus 2abxy, right, minus 2b minus 2ax, okay, b square y square, I have to write here b square y square minus 2ax minus 2by, and plus 1 equal to 0. You got it here. Now if you go for delta formula, start simplifying. ABC, that is what? A square b square 1, right, minus 2fgh plus 2, f is what? 2f minus b minus a, 2fgh ab, okay, minus ab. You are getting like this, 2fgh minus, okay, minus af square, f square means b square, minus bg square, bg square means a square, you are getting again, minus bg square, minus ch square, minus ch square means what? ab whole square, you are getting again like this. After simplifying this one, you see here ab square, again there is a ab square you are getting here, and here also what? 2ab square, this is ab square, right, we are getting here finally minus 4a square b square, we are getting minus 4a square b square, because negative, one get, you can cut it off this, the remaining all are there, na, 4a square b square not equal to 0, confirm. The question is delta is this represent conic, which one? Again we have to go for h square. Yeah, here I want to take little bit different, h square ab I'll take here. H square means just now I said it to you that while writing this one, h square is here minus ab, see, whole square, h square, a is what? A square, b is b square, so you are getting 0, right? H square is equal to what you got here? H square is equal to AB, you got it. H square is equal to AB means parabola, right? It is what? No, parabola, we got it. Yes, we start now parabola. What is parabola? Same definition, conic definition, the locus of a point P in a plane such that its distance from a fixed point is always equal to the distance from a fixed straight line. Now here I am saying that suppose if a fixed straight line is like this, P, S is for fixed point is in this way, what I am saying that this is M, SP by PM is 1, I said, that is SPM, SP is equal to PM, then we can say that locus of P is parabola, we said. Now the question is here, the see here, now the general equation of the parabola, or you can say that the equation of the parabola in standard form, right? The equation, see here, the equation of the parabola in standard form. In standard form, the equation of the parabola in standard form is y square equal to 4ax, right? Y square equal to 4ax. Now you see here, you want the proof, definitely we can discuss. what I am saying here, the standard equation, why we are calling this one as a standard equation? Here the proof. Here you take down one line, fixed line, right? What I am saying here is the S is a fixed point, P is one more point. According to the definition, this is PM. Draw the projection of, let S be the fixed point. You know very well that X is a fixed point, L equal to 0 be the fixed line. You know very well. P is a one point you are taken. Draw the projections of P and S on this fixed line called what? Directrix. This is directrix. You draw, and this one is Z, and this one we are going to indicate with M. Say like this. Now question is, if you draw a line perpendicular to directrix, passes through focus, you can say that axis of the, okay, you can say that axis of the parabola, you can call it as. Now what I am doing here I am assuming this line equation L equal to 0. Now you let us say like this, let P be the, now you see here what I am saying, that here let P be any point, P be any point, let P be any point, right? Let P be any point on the parabola, let P be any point on the parabola, I am assuming here. Now the next one is, what I am assuming, you see here, I want to take one point here, I want to define a point A. Let us assume that, this is what, let assume that A is a midpoint of SZ, midpoint of SZ. That means ZA is equal to AS. I am taking like this. Now here if I assume midpoint, I will consider AS as positive x-axis, right? What is that? Positive x-axis. If I take this as positive x-axis, okay, now I can say that x-axis, this is A, and here I want to draw like this perpendicular line. I'll say that AY is positive y-axis. I define like this. Now A become, at that time A become what? 0, 0. If you say that this is positive x-axis, positive y-axis, then A become what? 0, 0. Now when you say that A is a midpoint of SZ, directly you can say that ZA is equal to AS is equal to, say some A, some distance A, you take down some distance A. Then at that time S becomes A comma 0 and Z become minus A comma 0 you will get. And also you can say that the equation of the line, see here, equation of directrix. Okay, equation of directrix is what? X plus A equal to 0. According to the definition, now SP is equal to PM. What is that? Under root of X. This you take down x1 y1, no problem at all. X1 y1 you take down. What is that now? X1 minus A whole square plus y1 minus 0 whole square is equal to PM, means x1 plus A by root 1 whole square you have, not whole square, like this. Now go for SBS, you will get here x1 minus A whole square plus y1 square is equal to x1 plus A, you will get whole square. Now you see here y1 square is equal to x1 plus x1 minus A, x1 minus A whole square, x1 plus A whole square minus x1 minus A whole square you will get. So y1 square is equal to 4ax1, you are getting 4ax1. So locus of P is now y square equal to 4ax, we got it. See here, we got the proof in this one. See here, we wrote everything, whatever is there, we proved it that why we have taken y square equal to 4x as a standard equation. Now once you see here, in parabola, we notice these all points. Okay, diagram is like this, right? We said that this one is A, this one is S, this one is Z, right? We have taken one point here somewhere P, and we have drawn like this PM. We said like this. Now you see here some more points I want to tell you. If you draw a line perpendicular to axis of the parabola, and perpendicular passes through focus, you can call it as LL dash. LL dash is lattice rectum. LL dash is what? Lattice rectum. This is what? Tangent at vertex. This is, you know very well, axis. This is axis. And you know very well that this one is directrix. Okay, directrix. Directrix, axis, etc. We got it. One more point is also you have to know that this is focus, this is vertex, this is foot of directrix. Z is what? Foot of directrix. S is focus. This is vertex. This is foot of directrix. And one more point, if you draw any line perpendicular to, see here, perpendicular to axis, and it is going to cut the parabola in 2 points, then this is called as, you say that PQ. Say that PQ also, nothing will happen here. Some Q and R. Here RQ is what? Double ordinate. Double ordinate. We have given some name here, double ordinate. That means lattice rectum is also one of the double ordinate. Double ordinate means line perpendicular to axis and cut the parabola in 2 points. What are the 2 points means? If you take R is x comma y, then Q become what? X comma minus y. For this parabola y square equal to 4ax you have learned. Now the question is, if you learn this many points, is enough? Will get command in parabola? My answer is no. No sir. Here you are supposed to go for 4 diagrams. What type of 4 diagrams we have? See this. One is this one. See this now? One is this. We have 4 equations. Get clarity. You have to get the maximum clarity. Then only you can say, okay, then only you will get command. Get clarity as much as possible, get clarity. So 4 diagrams we have. One is this. The other one is, the shape may change like this. See this other one is this. Here S, here A, here Z. Now the other one is might be like this. See this? This is S, this is A, there is a Z. The other one may be like this. Like this. This is A, this is S, this is Z. So this equation is y square equal to 4ax. And this equation is y square equal to minus 4ax. And this equation is x square equal to 4ay. And this equation is x square equal to minus 4ay. What are the ingredients we have learned over here? Yes sir. We know very well what is A. Right? What is A? We learn this. This is, I'll write here directrix. Right? A and S and Z, and equation of directrix is also there. We'll talk about it now. Now A, what is A? 0, 0 in all the 4 cases. Right? And here also what? 0, 0 only. In all 4 cases the vertex is same here. You see that. But you please observe carefully after what is, if you think about focus, focus is always lies inside the parabola. In all the 4 diagrams you see that focus is always lies inside the parabola. So now when you are going to solve the problem, if A and S is given, what type of shape, whether it is yes, you have to take always inside. So please remember, this one will help you a lot. You have to observe like that. Now A comma 0, this is minus A comma 0, this is 0 comma A, this is 0 comma minus A. You got it. Z, quite opposite. What is that? Minus A comma 0, A comma 0, 0 comma minus A, 0 comma A. You got it. Now this length LL dash is in LL dash, you can call it as length of lattice rectum. What is that? Length of lattice rectum. That is in all the 4A, 4A, 4A and 4A you are getting. Another one is there. What is that? Here another one we can write. See here another one, directrix. Directrix, what is the equation of directrix means? Here equation of directrix. Equation of directrix, x is equal to minus A, here x is equal to A, y is equal to minus A, y is equal to A, you can say Here equation of directrix we got it. Another point we have learned, what is that? This tangent is also there as well as lattice rectum, equation of lattice rectum. See here, equation of LLR. What is that LL dash? X is equal to A we have. Another one is equation of axis. Equation of axis is y is equal to 0. Another one is also there, equation of tangent, right? Equation of tangent at A. What is the equation of tangent at A? That is x is equal to 0. We got it. Now please take care of this, right? These all 8 points are related to 1. Now in the same way we can write here also. What is that, Nana? Here x is equal to LL dash, equation of LL dash, equation of LL dash. You can write here LL dash. Equation of LL dash in this case is x is equal to minus a, and the equation of axis is y is equal to 0. A tangent is equation of tangent at A is x is equal to 0 in this way. But whereas here little bit change. What is that? You see here, equation of LL dash is equal to x is equal to A, not x. Here equation of y is equal to A, sir. This is what? Y is equal to A. Like this you will get, right? LL dash. Now here equation of axis is x is equal to 0, right? Another one is equation of tangent, right? Equation of tangent. Equation of tangent is, you see this one, tangent is what? Y is equal to 0 in this case. Same as it is you will get equation of LL dash. Equation of LL dash in this case, LL dash means this one, sir. It is like this. So x is equal to minus a, sorry, y is equal to minus a. Here x is equal to 0, equation of axis, right? Axis, and equation of tangent. It's at A, sir. Remember, at A. So y is equal to 0. We got it like this, all 4 points. So please remember, how many? 4 diagrams. Whenever the question is given, based on that you have to write the formula. Let us see some examples on this one. Guys, I would like to show you that whatever the points now you have learned in this diagram, those all things, once let us execute by taking some examples. Suppose if I gave you like this, y square is equal to 8x. One example I have taken, right? For this, what you know, you please try to write. Suppose if I said it to you that write all the points related to this, what you are going to write? First thing is you take down 4a. Compare with y square equal to 4ax. 4a is equal to 8. A is equal to 2 you will get. Once you got it, a is 2, you start writing here length of lattice rectum. That is what? 4a, 8. Next one, once you got it A, you can write here, anyhow you know very well that focus, anyhow you know very well that A is 0, 0 and S is what? 2, 0, because A comma 0 na, that's why we are writing. Now Z is what? Minus 2 comma 0. Why? Minus A comma 0 you have learned. Z is this one. Now here equation of directrix, x is equal to minus A, that means what? X is equal to minus 2 is the answer. Right. Another one is equation of lattice rectum, x is equal to A it is, that is nothing but x is equal to 2 is the answer. This is the answer. 4 points. Here you see this one. First one is this. First one is this one. Second one. Third one. Fourth one. Fifth one. And 6th point. Minimum 6 points related to this one. 6 points. If you write, this is good. Now you see, suppose if I gave you the equation like this, y square equal to minus 16x. If I said it to that, write all these points. Need not worry. You take 4a is equal to 16 and a is equal to, you will get what? 4. Yeah, fine, very good. Now length of lattice rectum, first of all you want to write 4a, that is 4a only. Don't take my negative, 4a only, that is what? 16. Now next one is a is same as it is, 0, 0, need not worry, 0, 0. Here another one is yes. Yes is very clear. What is the shape of the diagram? For roughly if you want you can draw like this. S may be inside, left side of, okay. Here A if you say left side, that means what? A is origin, left side is there, therefore definitely negative. Minus A comma 0, that is minus 4 comma 0 you get. Z this time is positive, A comma 0, that is 4 comma 0. Now equation of directrix. Equation of directrix is also what? Very simple. What is that? X is equal to A we are getting, that is x is equal to 4 is the answer. Right. Equation of lattice rectum LL, x is equal to minus A, because it is like this, L dash. So x is equal to minus 4, you can write here in this way. Right. In this way you can write. Oh, what are the points? 1, 2, 3, 4, 5 and 6. Please remember like this. Now if I want to take one more example. X square is equal to, suppose 12y is there. What is the diagram means? You can draw like this. Rough diagram, you know very well that it is the diagram. S is somewhere here, A is this, Z is this. Now in the same fashion you can take that 4A is equal to 12 and A is equal to, you will get what? 3. Once you got it A, the story start once again. What is that? LL dash, that is 4A. Length of lattice rectum, right? 4A is nothing but what? 12, you got it. Second one is what? A is anyhow 0, 0 is there. And third one is S. S this time is S is 0. What is that? 0 comma A, that is 0 comma 3 you can write. Z is 0 comma minus A, that is 0 comma minus 3 you can write. Right. Another one, fifth point I want to write here, equation of directrix. Equation of directrix is y is equal to minus A, means minus 3. Now next one is equation of lattice rectum. Sixth one is equation of lattice rectum. See here, equation of lattice rectum is y is equal to 3 you will get. Why? Because this is y is equal to 3. Right, this is y is equal to minus 3. This is x axis, this is y axis. Like this you are going to get now. So like this. So examples are given. I have taken 3 examples. I got it like this, in this way. Now you see here the same equation. What I am doing here, you see this now. I want to transform this equation to origin to some other point h comma k. This is what A, Z as it is. S is there, but I transform origin here, x axis. I transform this one to h comma k. Then the equation becomes y minus k whole square. I transform, origin is transformed to h comma k. So I'll get like this, 4A into x minus h. At that time, what is going to happen? You see here, A, if I said that like this is the transformed equation. I want to write here A. What is A nana? 0, 0. Not 0, 0 at that time, h comma k. I transformed A. Now A, if you want to write here, yes. S is what? A comma 0. Just you add h and k, that's it. The general equation you know very well, that y square equal to 4ax. For whatever the points you have learned, you add h and k in this way. You see here I added 0 plus h, 0 plus k means h k, I got it. S is what? H plus, okay, h plus a comma k. You see here s is actually a comma 0. I added h comma k here. Now z is there. What is z? H minus a comma k. But in this case also, length of lattice rectum is same, no change at all. And also equation of directrix is also what? Change here. How? X is equal to h minus a you can write. Right? X is equal to x minus a. And in the same way, LLR, and another one is what? Equation of, see here, equation of length of lattice rectum. Equation of lattice rectum is LR, sorry, equation of lattice rectum is what you can write? X is equal to h plus a you can write. 6 points I am focusing. Okay, axis, you know very well that. Axis means what you have to write here? This is y is equal to k. Axis, now you see here, axis is y is equal to k. Okay, equation of tangent. Equation of tangent. Tangent at A, you can say that x is equal to h. You can say like this. Okay, now in the next one, I want to take the same equation. If I take in this way, if it is like this, then the story is like this, sir. Here minus 4a into x minus h you have to write. This is what? H comma k as usual, but h minus a comma k you have to write, and here h plus a comma k you have to write, but 4a is same as it is. But whereas here directrix is h plus a is a directrix, and here h is equal to, sorry, x is equal to h minus a is lattice rectum, y is equal to k, and x is equal to h is what? Same as it is, axis as well as tangent. Here axis and tangent here. Now in this case, right, remember this is a, z, Yes, and you can transform. What are this? These are what transformed forms, sir. Nothing is there. Transformed form. These are just a transformed form. X minus h whole square is equal to 4a into y minus k. In this case, a is this one. Okay, s is 0, not h comma k plus a is h. K plus a is h. Z is, see here, h comma k minus a it is. LLR is what same as it is. Equation of directrix. Directrix is y is equal to sum. Y is equal to k plus a, sir. K minus a. Sorry, y is equal to k minus a. You can take. And now here equation of lattice rectum. If I said here equation of lattice rectum is like this. Y is equal to, you can take here k minus k. This is y is equal to k minus a, na? This is y is equal to k plus a, you can take. Right. Axis, you know very well that axis here, axis is x is equal to h and tangent is y is equal to, tangent is y is equal to k, you can say. Quite opposite. Right. One last diagram is there. You can say here, see this, if it is like this, you can say a is equal to h comma k in this case, s is equal to h k minus a, z is equal to here h k plus a, quite opposite. 4a is same as it is, y is equal to k plus a here and y is equal to k minus a here, x is equal to h and y is equal to k, same as it is. This is what axis, this is tangent. Right. Like this we are going to have all those things. Right, sir. One example I have taken here. Find the coordinates of the vertex, focus, foot of directrix, equation, lattice rectum and equation of axis. You see here transform form is given, y square plus 4y plus 4 I'll write and take the side, x minus 1 will get. So this become what, y plus 2 whole square equal to x minus 1 we have. Now when you start comparing here, y minus k whole square is equal to 4a into x minus h. Yeah, you can compare here. That is what, 4a is equal to 1 you are getting, a is equal to 1 by 4 you got it. And a you can write directly. What is that? 1 comma minus 2. This is h comma k, sir. This is your h comma k you are getting here. Now a want to write. Yes, you want to write here h plus a comma k, that is h is 1. A is 1 by 4, k is what? K is minus 2. K is minus 2, you got it. Z is equal to h minus a comma k, that is what, 1 minus 1 by 4 minus 2 you are getting here. Right. And the equation of directrix is very simple. Here x is equal to, you see here the diagram is also, you know very well that it is transformed form. Right. So here equation of x is equal to h minus a, you can say that this is the formula. X is equal to h is what, 1, a is 1 by 4. Right. Finally you will get here 4x minus 3 equal to 0. 4x minus 3 equal to 0, you got it. Now here equation of axis, very simple. Equation of axis is y is equal to k, sir. So y is equal to k means y is equal to, see here y is equal to k. Y is equal to k means what is the value of k here? Minus 2. Right. Y is equal to minus 2. Here we got it. See here he said that vertex, yes, focus, yes, foot of directrix, yes, equation of the directrix also we got it. Equation of another one, equation of lattice rectum. Equation of lattice rectum is x is equal to h plus a, you have to say this is. Okay, so x is equal to h is 1, a is 1 by 4, so that is 4x minus 5 equal to 0. This is the way. Okay, thank you guys. I'll stop here. We'll continue in the next class.